Welcome to Digital Learning Day. I'm Lori Pringle. I'm an educational consultant with WOUB out of Athens, Ohio. I'm also the district librarian of East Holmes Local Schools. I'm excited to be presenting block coding for Digital Learning Day with the Ohio EdTechs. Let's get started. So the goal of this presentation is to share with you ways to integrate coding into your curriculum using block-based coding. The focus will be on resources for kindergarten through 12th grade. Notice the presentation link below that you can use to access the Google Slide presentation, so you can click on all the links that I'll be sharing throughout the message. So let's get a coding overview. Coding is a means for creating a sequence of instructions that tell a computer what to do. Coding is used to create software, apps, video games, websites, and more. Coding is also considered computer programming. It's a type of literacy. Just like we learn writing and reading and math, and we use things to organize our thinking, coding is doing that with computers. Don't think of yourself as a coding expert and think, I can't do coding. Think of yourself as a lead learner and explore coding and teach it just like you would any other literacy. Let's review some languages of coding most often taught in kindergarten through 12th grade. Blockly is the first example. Things like code.org offer great free introduction courses to coding using Blockly language. It's specifically designed for helping students of any age new to coding. More advanced lessons are also included on resources like code.org. Another option would be Scratch or Scratch Junior. Scratch was developed by MIT and made popular by Google's CS First curriculum. Scratch, like Blockly, is a visual programming language, and it uses graphics or color-coded blocks of instructions that are easy to understand. Older students can move into Java. This is often the first text-based programming language used for coding of very specific terms with punctuations. It works with kindergarten through 12th grade. Java is probably best known for its languages in advanced computer classes and is sometimes considered real programming. JavaScript is another option. Perhaps JavaScript is best known from websites like code.org, where students master the basics of coding and then they can move into the JavaScript and move more quickly and more advanced. Swift is another language that's used most often by Apple to create apps for the Apple devices. You can explore Swift playgrounds and resources for those wanting to teach Swift. Python is a final option that's popular in kindergarten through 12th grade. It's especially used with students with resources like the Raspberry Pi. It's a special type of computer programming, which is fairly easy to use and is often used with building robotics or other resources. Python is a very popular coding terminology or language for real programmers. So you might think, how would I integrate coding into my curriculum? Just be creative and think about ways and places it might be. Could it work inside your course? Or maybe you want to propose a new course in your school that would be focused more on computer skills. Some schools like to do coding at family events or STEM days. Even just integrating an hour of code once a week or once a quarter. Some enjoy coding clubs or after-school programs. Maybe coding fits into your station rotation, into your enrichment program, or in a special makerspace environment where kids can experience and explore coding. Start brainstorming how you could integrate it into your curriculum. Oftentimes I get asked about coding with Chromebooks. There are actually several web-based tools that work great for Chromebooks. You might explore Scratch. It's a free resource, has some great educator guides, tutorials, and even educational meetups where you can connect with other educators who are using Scratch. Have you ever experienced Microsoft MakeCode? That's a great free open source platform as well. It has simulators, block editors, and JavaScript editor explorations as well. You can use Microsoft MakeCode with the Q, Legos, or even Minecraft. Some teachers enjoy Tinker. If you haven't explored Tinker, it's a great web-based resource you might want to check out. I think of Tinker primarily for kindergarten through 8th grade, but they do contain some content as well for the older students, some great free resources such as their Hour of Code challenges, and they do offer a paid site as well. Maybe Workbench Education is a site you want to explore. It's a K-12 integrated program that works right within Google Classroom, so that's a plus if you were a Google Classroom school. And it is free, and they offer customizable lessons as well. Code.org is a great resource for teachers for teaching computer science and coding. It's discovery-based, and it's a curriculum you can use with just a free sign-in. You can explore and all their content. You can use their webinars and more. Or if you want to learn more about it, they do offer professional development in our area. The Ohio EdTechs are offering deep dives this spring, so you can search for those on the code.org website or on the Ohio EdTech individual websites as well. There's another option for Ohio educators if you really want to get involved with code.org. This summer, there'll be a week-long training hosted by Battelle for Kids in July, and it is a fee-based training. However, you can apply for a scholarship based on your school's free and reduced meal rate, or scholarships are also given for rural regions or regions serving the underrepresented minority groups. So check out the code.org website to learn all about those different professional learning opportunities, or just explore the content on your own. If you're working with primary kids and you're just wondering, why do I want to teach coding in kindergarten or preschool? Does that really make sense? This is a great little video clip that you can watch on your own that really explains and helps paint the picture of the importance of coding with primary children. It paints a picture of the importance of coding with primary children. So now I'd like to share some examples of different coding experiences with different grade levels. I'm going to start at the preschool and move through high school. So this first example that I'm going to show you were preschool children that did kinesthetic coding with Scratch Junior cards, as in this photograph. We laid out the cards and we created a sequencing that we could do kinesthetically, representing coding language. This is a fun activity to do even with Simon Says, and I have a link there to the printable Scratch Junior Simon Says if you want to do something like that with younger children. Let's watch this example of how these kids use these coding cards to kinesthetically experience a coding sequence.
I won't say it. You watch. So what do we have to do first? We have to do what? Okay, and then what do we do? Yep, and then what do we do? And then what's next? And then what's next? And then what's next?
Squeak, squeak, squeak.
And then? Good job. Give yourself a hand. Woo, we did it.
Junior and PBS Scratch Kids are creative coding apps that you can use with your children to allow them to do simple block-based coding with their favorite sprites. In the next example, I'm going to show the same group of children. After we did the kinesthetic coding, we introduced the iPad to the students and opened up the Scratch Junior PBS app, and right away they transferred their knowledge to the iPad and were able to quickly create sequences of coding for their sprites.
He's going to get big. Yep. And then does he want to move again? Or does he want to get little? Get big again? Because remember on the cards, we went, you want to go big and little. So he's going to change size. And then we could test it up here. Okay. Do you want him to go? Do you want him to move? You just want him to get big and little, big and little? Then is he going to move? Or you want to make him make a sound? Okay, you have to pull it down. Remember, add him to the code. There you go. Okay, let's test it with the green flag. See how he got big and little? And then he went pop. Because you told him to get big, big, little, big, little. So he went big and little. And then he made the sound at the end. He went pop.
I don't know.
PBS Kids offers lots of other apps as well that help support STEM, social emotional literacy, and much more. Let's move into the education of elementary students now with Dash and Dot. Wonder Workshop is a great resource. It is a purchased robotic that you would purchase. You can purchase Dash and you can purchase Dot. And those resources are great for upper elementary as well as younger elementary. And you could really stretch them into the older grades, encouraging them to use them as well, especially if they're new to coding. So I'm going to show you a couple examples. In the first example, students were able to code a musical sequence, and Dash is going to play that for you on an xylophone. Now let's take a look at another example. Let's look at these upper elementary students and how they took the Dash robot and they programmed him to follow a specific path and stop and pick up a block and move on about his path. They were really excited to see this all fit together. They had to do a lot of playing with that. If you liked what you just saw with the Blockly Dash and Dot resources with those student examples, be sure to visit their website. I do want to mention I don't work for Wonder Workshop, but I love their products for elementary students. Be sure to check out their two different types of robots they offer. You saw Dash. That robot is recommended for 6-year-olds and older. Wonder Workshop also offers a Q robot for 11-year-olds and older that is a bit more advanced. You notice the accessories in our video clips. They offer lots of fun accessories for students to use. Be sure to check out their robotic competitions, which are really cool because they're free to enter and they're virtual, so you don't even have to travel with your students. They have free lesson ideas and extensions on their online website, but you can also purchase coding challenge cards and resource guides full of lesson activities to support your teaching. Be sure to check out their device compatibility as well. That way you can know if Dash and Dot are going to work with your devices that are in your building. It's your lucky day. Do you need PD credit? Check out the box in the lower corner of the screen, and you can get professional development credit for watching this presentation that you can submit to your local LPDC for continuing credit. Let's move into the high school now. At the high school level, you might experience Google CS First. That's where I got started with coding. I did it as a club. Students could do it in my library, and we set up the Google CS First challenges, promoted those through the school. And what's neat about those is students can watch the videos and self-teach through the Scratch programming and the Google GS First presentations. Another option at the high school level is you might explore robotic lessons or robotic competitions. Lego has resources for high school, Sphero, and Vex. And I'm going to show you a little Vex presentation. This is a robot that was built collaboratively. And then just very beginning coding was taught, and the students were able to quickly catch on and program their Vex robot to do a simple sequence. I love Common Sense Media resources. Be sure to visit their website for an awesome Get Started with Coding guide as pictured in the presentation. They also have links to the best apps and websites for learning programming coding. And then depending on the grade level that you teach, you can get the best coding tools for elementary, middle school, of high school. And those include websites and apps. Just a wealth of information to support you as you move through coding and challenge yourself to integrate it into your curriculum. And here's a bonus just for you. If you're like me, you might wonder, how do you do online presentations like this? For this presentation, I used Screencastify to capture myself talking within my Google Slides presentation. And then I used WeVideo to do some simple video editing. Both services offer free educational versions as well as paid options too. Well, our time together has come to an end. I want to thank you for joining us for Digital Learning Day 2020. I hope you gleaned some great information and are excited about exploring coding and integrating it into your curriculum. If you have any questions, feel free to contact me. My contact information is in the lower corner. The presentation link is also on this slide. And don't forget the question and answer document that you can use collaboratively to ask questions and get your questions answered. Thanks for joining us.